All right, so this week we're gonna put everything together. It's a slope from multiple representations. Now we did graphs, we did tables, we did equations, and then we took the slope from equations, from graphs, from tables, and also we read word problems and took the slope from there. So we're gonna do a whole thing together. So let's do everything together. In the first examples, I'm gonna find the slope. So it says find the slopes of each of the lines. So I'm gonna go ahead and find the slopes for each of the lines. So find the slope of A. So A is over here. I know this is a negative slope. It's going like downhill over here. So the first thing is to find 2 points. I'm gonna find 2 points. There's 2 points over here. Count two down. So rise over down, run, right? So two down. So 1, 2, 1, 2, 3, 4, 5. So my rise over run, which is my slope. Remember, it's always y over x, right? So rise up and down first, and then to the right. So to the side. So 1, 2 down, and then we set 5 to the right. So notice that my slope is negative, and that's it. Let's find the slope for B. B is, if this is y and this is x, B is a horizontal line. And we said that the horizontal line always has a zero slope. It has no inclination. So there is a slope of 0. So the slope, rise over run, it would be 0. All right, so find the slope of line C. Line C is a positive slope. It's going up, uphill, right? So then I'm gonna find 2 points that I can see. So that's one here, one here. Oh, these are 1, 1. So my rise over run is 1 to the right, one up, one to the right, which is the same thing as 1. That's my slope. All right, so that line D, what's line D right here? So we said that when there is a vertical line has an undefined slope. There's no way I can take a slope from there. I know this is a 0 slope, but this one is undefined. We can't find it. There's no way. It's a straight line up, like vertical. Can't find a slope. There's no inclination there. So undefined. So vertical lines, this is vertical lines, and this is horizontal lines. Okay. All right. So let's find the slope some other way. Another representation of slope that we learn is using the slope formula, where y2 minus y1 over x2 minus x1 gives you the slope. And my 2 points, these are my 2 points basically. So I have 2 points, and when I have 2 points, then I can find the slope there. All right, so my formula is y2 minus y1 over x2 minus x1. So that minus that and that minus that basically. So let's substitute 8 minus negative 2, and then 4 minus, 3, sorry. I messed up. So 8 minus 3, which are the y's, and then 4 minus negative 2 to find my slope. Notice that if I mess up, then I get a wrong number, right? I almost did. So 8 minus 3, that's 5. And then this minus minus is a plus, so 4 plus 2, that's 6. And that is my answer. I can't simplify anymore because 5 is a prime number. All right, let's do another one. So that minus that, and that minus that. So that's 2 minus 6, and then negative 5 minus 7. 2 minus 6, that's negative 4. And then negative 5 minus 7, that is negative 12. And then that becomes positive because they're both negative. So that's 4 over 12. And then that also simplifies. If I divide by 4, I get 1 over 3. And that is my slope. Okay, my slope is 1 up, 3 to the right. All right, so with that, that's using your formula. So we did graphs, we used the formula, Nice. Now let's use tables. So to find the slope in a table, you can also use the formula my2 minus y1 over x2 minus x1, and just use 2 points, right? Because this one is 1 point and this one is another point. You can do that. But another way to do it is to find the difference, the patterns between the y and the pattern between the x, and then it's going to be y over x. So then, so my rate of change would be y over x. First y's, then the x. All right, so let's find a pattern. So from 8 to 12, that is increasing. So it's increasing by how much? By 5. Each one, notice, there is a pattern. Now this one, it's increasing plus 1, right? So now my pattern is 5. Remember, it's y over x, so it would be 5 over 1. So y over x would be 5 over 1, which is the same thing as 5 divided by 1, which is 5. So remember to simplify. Let's do another one. So it says, is this a linear function? Yes, it is, because it has the same differences, like the same pattern. So it goes up by a pattern or down by the same pattern. So yes. So this one, we notice that it's decreasing by 1. Notice, decreasing by 1. And this one, it's increasing by 3. So my rate of change, which is y over x, would be negative 1 over 3. And that's all I can do because that's simplified enough. Once you have a 1 on the numerator, then it's simplified. Is this a linear function? Yes, it's going by the same number. It goes up, it goes down by the same number and up by the same number. So yes. All right, let's do this one quick. So this one goes plus 5, right? Plus 5. And this plus 1. So same thing here, rate of change. So y over, oh, but check it out. It changes. This one goes by 5, but this one doesn't skip any numbers. So this one goes by 10. This one goes by 20. This one goes by, yeah, by 40. So this is definitely not a linear pattern. This goes up like maybe exponential or something like that. This is, you can't take the slope of this thing. So we can't do here nothing. But here we can say that it's not a linear function. So notice that in each of these tables. I almost made another mistake there. All right, cool. All right, let's do this one. So now we have 3 representations. We have a graph. We have using the slope formula, and then we have a table. Now we have to do one more representation. It's the stuff we did last week, which is a word problem. So Roger is typing a 1,200 word essay he had written by hand. Roger averages 75 words per minute. So that's our rate of change right here. Roger had already typed 150 words. So he started with this. So this is your y-intercept right here. So this is your rate of change, which is your slope. And this is your y-intercept. So in y equals mx plus b, that's what happens. So what is your constant rate of change? Well, it's 75 words per minute. And then what is the initial value? Well, 150 words. I'm going to use W for words. So what's my equation? It would be y equals mx plus b, where m is your rate of change, which is your slope. So y equals 75 times x plus your starting value, which is 150, which is your y-intercept. Remember, y-intercept is the point that intersects the y-axis. Is where everything starts. Okay, let's do another one just in case. So it says Jeff has a cell phone plan that charges 9 cents per minute plus a monthly fee of $23. All right, so this one, it says, what is your constant rate of change? So your constant rate of change, it says it's this one. It's not the small one now, it's the big one, because this one is the one that they're charging monthly fee of 23. But it says, let's read it again, has a cell phone plan that charges 9 cents per minute, but also has a monthly fee of 23. So you have to start by the initial value is 23, almost messed up again, 23, and then it charges per minute 9 cents. So this is your constant rate of change. Now it depends how many minutes, that's why how much you're going to be charged in the total cost per month, right? So this changes. So this is per minute, and this is the initial value. So in your y equals mx plus b, your slope is this one, and your y in your b, your y-intercept is in which is b. Y equals 0.09 times x plus 23. And that's your equation. So here we did four representations of slope. One, it was by graphing. The second one, it was by looking for the slope, having the formula. And then the third one was the tables. And the fourth one was the one we did last week, which it was word problems. So I hope this helps. Have a nice day.